Hello everyone, and welcome back to another video about IB Math. In today's lesson, we will be studying an important topic in the IB Math AA high level, which is differential equations. Differential equations come in various forms, like separable differential equations, homogeneous differential equations, and differential equations that can be solved by integrating factors. In today's lesson, we'll be focusing on separable differential equations, where we can separate variables x and y on each side and then integrate easily. So to simplify the concept, we will have many examples starting from easy ones to hard ones. So let's now start with this very simple example. Here we have a differential equation dy over dx equals 2x. Now this is a differential equation because it has a derivative dy over dx. Our aim here is to eliminate any derivative at the end by integrating, so that at the end we get only y, not dy over dx. Here, it's easy to integrate here. When we integrate the left side, dy over dx, it will be just y, because we know that when we differentiate y, it will be dy over dx, which means when we integrate dy over dx, it will be y. So here, when we integrate this, it will be y, and when we integrate 2x, it will be x squared. So basically, y is equal to x squared. But here, we'll do it in a slightly different way to get used to differential equations better. So first, we will separate the variables by cross-multiplying. We will multiply dx by 2x. So now we will have here dy is equal to 2x multiplied by dx. Notice that we have only x on the right and only y on the left, so we separated the variables. So now it's ready to integrate both sides. Here, when we integrate the right side, it will be x squared as we said. But when we integrate here, dy, it will be like, if we have nothing here, it will be 1. So we're integrating 1 with respect to dy. We know that when we integrate 1 with respect to x, or here like dx, it will be just x. So when we integrate 1 with respect to y, it will be only y. So we will get y equals x squared plus the constant of integration c. First, keep in mind that the constant of integration, we put it here on one side only, not both sides. So it's an arbitrary constant. So here we got the general solution to this differential equation. And actually these are infinitely many solutions. You will get different solutions for every different value of c you put here. And really, these are all solutions to this differential equations, because when you differentiate this, you will get 2x, which means it's a solution. Now, let's move on to another example. Here we have dy over dx equals 2x over cosine y. We notice that here, this side has a mix of x and y. So first, we will separate the variable by cross multiplication. We'll multiply dy by cosine y and dx by 2x. So we will get this. Here, we're given a condition or a point for the solution that we will talk about at the end of this solution. Notice that here we separated the variables, all the y's on the left and the x's on the right. So now we will integrate both sides individually. Here, you know, when we integrate cosine x, it will become sine x, as we know that from the rules that are given in the IB Math booklet. So in the same way here, when we integrate cosine y with respect to y, it will become sine y equals, here when we integrate 2x, it will be x squared plus c. So here, as you see, again, we got infinitely many solutions, and for every different value of c, you get a solution. So here they need a particular solution that passes through this point. When you replace x by 1, y will be 0. So we need a solution that passes through 1, 0. It means we'll replace x by 1 and y by 0. So here it will be sine of 0 for y. And we will replace x by 1. So here we'll have 1 squared plus c. Sine 0 is 0. So here we will have 0 equals 1 plus c. And that means c will be negative 1. We take this value of c and put it here in this general solution. So we will get this particular solution now. Sine y is equal to x squared minus 1. So this is the particular solution to this differential equation that passes through the point 1, 0. Here we will try to make y the subject if we can. Here we can solve for y. To solve for y or get it out of the sign, you will use the inverse of the sine function, which is arc sine. So here y will be arc sine of the whole right side. We know that, for example, if sine A is equal to B, then if you need to get A from the inside of sine, it will be arc sine of the whole right side B. So here y will be arc sine of the right side, x squared minus 1. This is now the solution to this differential equation. Here now we have another example. Again here we need to make or separate the variables x and y. So first I will multiply both sides by dx to move dx to the right. So here we will have this. And then we still have here y on the right. So we will divide by e power of 2y to move it down under dy. So we will have now 1 over 2y, 1 over e power of 2y dy will be equal to this. Or you can write it as dy over e power of 2y, which is the same. After we separated the variables, now y is on the left and x is on the right, we can integrate both sides like this. Here, 1 over e power of 2y, I wrote it as e power of negative 2y for integration to make it easier. We studied before in a previous video about the basics of integration that appears top right of the screen, that if we integrate e power of ax dx, for example, first when we integrate e, it will be the same, e power of ax, but we multiply by 1 over a, the number multiplied by x. So here, to integrate this, we put 1 over negative 2, which will be a negative half. So 1 over negative 2 multiplied by the same e. In the same way, we learned also, when we integrate cosine 5x, it will be sine 5x. But again, we multiply by 1 over a, which is the number multiplied by x, 5. Plus the constant of integration c. Here, we'll make y the subject. So first, we'll eliminate this negative half by multiplying by negative 2, both sides. So here, if we multiply this by negative 2, the negative half will be eliminated. And here, if we multiply 1 over 5 by negative 2, it will be negative 2 over 5 multiplied by sine. Also here, if you multiply c by negative 2, it will be negative 2c, which is still an arbitrary random constant. You can name it a new name, for example, capital A. Or you can just keep it c, like this. So that's why I kept it c here as it is. No need to write negative 2c. Now, to put the y down, we need to use natural logarithm for both sides. So I will take ln, or logarithm, for both sides. Here, the logarithm will let the negative 2y down. And then we have ln e, which is 1. So that's why we have here only negative 2y equals ln of the whole right side. Then finally, to get y, we need to divide by this -2. So we will have negative half, or 1 over -2, multiplied by the same ln. This is the general solution to this differential equation. Now, we will move on here to a very interesting differential equation. Here, we have x's on the left here and y's on the right. So here on this side also we have y and x, as you see. So we will separate variables. First, we'll multiply both sides by dx. So now we will have, on the right, we will have 1 plus y squared multiplied by dx, but we still have y and x on this side and here. So I will divide both sides by 1 plus y squared to move it down here, and also by 1 plus x squared to move it down under dx, to get the x's together and the y's together. It will be like this. And now, since we separated the variables, we will integrate both sides. So, we studied, and also it's available in the formula booklet, in the IB formula booklet, that when we integrate 1 over 1 plus x squared, it will be arctangent x. And the same way, this will be arctangent y, because they are the same, but instead of x, we have y. So when we integrate both sides, we'll have arctangent y equals arctangent x plus c. Now, here also we need to make y the subject. So here, if we make y the subject, we need to take it from inside of the arctan. So we will use the inverse of arctan, which is tangent of the whole right side. So to remind you, when we have tangent A equals B, or here no, it's arctangent. When we have arctangent A equals B, then if you need to get A from the inside, it will be tangent of the right side B. So here, y will be tangent of the right side, which is this. Now here, we're given a condition that y0 is 5. The solution must pass through the point 0, 5. X is 0, y 5. So replace here y by 5 and x by 0. We will get now 5 here instead of y and 0 instead of x. Here, arctangent 0 is 0, because we know that tangent 0 is 0. So here we have 0 plus c. 5 is equal to tangent 0 plus c, which is c. So if we need to get c from the inside, it will be arctangent 5. Now, take this c and put it in the solution here. So y will be tangent of this. Instead of c, we put arctangent 5. So this is the final particular solution to this differential equation, but we will simplify it now in a nice way. Here we have tangent of this plus this, which reminds us of this formula that's given in the IB booklet. Tan A plus B can be written like this. So we'll apply it here literally. We'll imagine that this is A and this is B. So now, according to the formula here, we have tangent A. So tangent of A, which is this, tangent of arctangent x. The tangent and the arctangent will cancel each other, so you will have only x. Here, for example, tangent of arctangent, anything inside like x, these will cancel, so you have only x. So this will simplify only x. In the same exact way, we have tangent of arctangent 5. So the tan and the arctan will cancel, so you have only 5. So you have x plus 5. Here it is, x plus 5. In the denominator, as you see in the formula, you have here 1. So we have 1 here, minus the product of the same two tangents above, these. So here, 1 minus the product of the two tangents above, x times 5. So it will be 5 times x. I wrote the 5 first. So here, tangent of this multiplied by the tangent of this will be 5x. This is now the particular solution to the differential equation given that passes through the point 0, 5. I really hope that you have enjoyed the video. Please hit the like button and consider subscribing. Thank you for watching.